So guys, in today's video we are going to look for physical properties of alcohols and phenols, and also we are going to see the acidic nature of the phenols in this video. So coming to our topic, the first important concept we are going to see is the physical properties. So as in the case we have learned in haloalkenes and the haloarenes, the same scenario will be looked after over here too. That is, with respect to the boiling point, with respect to its solubility, with respect to their important isomers, how does the boiling point of the alcohols are going to vary. But before going to this important topic, let me make you one thing clear, as we have said in haloalkenes and the haloarenes. So whenever we are dealing with the boiling point, we have to make sure that we want to compare the boiling point with the van der Waals force. That is, if the van der Waals force increases, the boiling point also increases. This is an universal truth. You should remember. Even though whatever the organic compound it would be, it could be an haloalkenes or haloarenes, or even it may be an alcohol, you have to make sure that if the van der Waals force increases, boiling point also increases. One important thing. Second most important thing, we have to remember that as the surface area, what I am saying, as the surface area increases, remember what happens? Your van der Waals force also increases. Why I am saying this? Because many times, for example, when I am talking about the branching and that of your normal cases, that is a straight chain and a branch chain, there I have to use the concept of this surface area. So in that case, there will be a certain ambiguity. For that reason, before entering to the mainstream of my topic, I am making you two important things clear. What is that? Whatever the boiling point we see, it mainly depends upon the forces. So it may, in case now if I am dealing with now alcohols, I am majorly concentrating about the van der Waals force. As the same scenario was seen with respect to your haloalkenes and haloarenes also. There also we have seen that as the van der Waals force increases, boiling point also increases. First important thing. And the second most important thing is what? As the surface area of your structure increases, van der Waals force also increases, but generally there will be boiling point also will be increasing. Okay. Coming with respect to the solubility, we know what? If a compound is soluble, for example, if I'm taking water, more particularly since water is an universal solvent. So if a compound has to be soluble in water, means it should have the ability, that is, that compound should have the ability to form hydrogen bonds with water. To form hydrogen bonds with water. So these are the important points I would like to make you clear before entering to the mainstream of my physical properties of alcohols and phenols. Okay. So first important physical property, let us see with respect to the boiling point. So what they say over here is, remember, the boiling point of alcohols increases. Okay, boiling point of the alcohols increases with increase in the number of carbon atoms. So what does it mean? Let me give you an example. So for example, now if you are having ethanol, CH3CH2OH one side, and in the other case if you are having CH3CH2CH2OH. So now if your question is asked that among ethanol and propanol, which will be having the higher boiling point, what will be your answer? I repeat, the question is among your ethanol and propanol, yes, which one will be having the higher boiling point? Of course, the answer is propanol. What is the reason? Yes, sir, because you only said boiling point of the alcohols increases with increase in the number of the carbon atoms. So when we are looking for ethanol, it is only having the 2 carbon atoms. But when we are looking for propanol, it is having 3 carbon atoms. So since in propanol we are having the higher number of the carbon atoms, of course the boiling point also increases. If I ask a question, why? Because the natural human tendency in science to ask why. Remember, with the increase in the number of the carbon atoms, keep in your mind van der Waals force also increases. I repeat, with increase in the number of the carbon atoms, van der Waals force also increases, and as I have said earlier, as the van der Waals force increases, boiling point also increases. Okay, so one important point we have come to know with respect to the boiling point of your alcohols, what is that? With the increase in the number of the carbon atoms, the boiling point of the alcohols also increases. If you can just recall, the same point was also repeated in your haloalkenes and haloarenes physical properties. Alva, there also we have seen, as the number of the carbon atoms increases, there also the boiling point increases. Okay. Coming to my second note over with respect to the boiling point itself. Now, in case if you are having the straight chain and that of your branched chain. For example, if I am taking CH3, CH2, 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 OH, and in the other case if I am choosing CH3, CH3, 1, 2, 3, 4, CH2, OH, 2, 3, 4, yeah. So what is this? Of course, now this is your N-butanol, whereas this one is your isobutanol. I'm just giving my common names. So one important thing I have to just make sure of you, what is that? Of course, these two are what? Isomers. Alva. One is a straight chain, another is a branch chain, so they are coming under the category of structural isomers. But in most of the cases, some pupils are having a doubt. So why we are using N over here and why we are using iso over here? Let me clear you that part. So here N means normal, that is a straight chain. Whereas an iso means what? Is an isomer. Then how to write it? Remember, majorly in an iso structure, the second carbon atom will be having a substituent as a methyl group. I repeat, whatever the iso part will be there, Alva, it will be an isomer of your straight chain. It will be an isomer of a straight chain. And how to write it? So whenever you are writing an iso structure, okay, the second carbon atom should have a methyl group as a substituent. Then we will be saying that structure as an iso respective compound. So in this case, isobutanol. For example, I'm just giving you an example. If I'm having a structure of a pentane, CH3, CH2, 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 CH3. What is this? It is N-pentane. If I want to write its isopentane, of course, it should be an isomer. That is, I should intact my mind in such a way that the molecular formula should be same, but it should be having a different structural formula. So I want now my isopentane. So of course, what is the hint I have given? So whenever I have to write an isomer, that is my isopentane of my N-pentane, the one hint what we are knowing is the second carbon atom should have the methyl group attached to it. Okay. So let me write CH3. This is my first carbon. In my second carbon, let me write here as my CH3. Okay. So here now I will be writing my H. So 1, 2, 3, 4. Sorry, 1, 2, 3, 4. So then CH2, then CH3. Yes or no? So what we have done, the only difference is what between the two structures. You can just see 5 carbon atoms, 1, 2, 3, 4, 5 carbon atoms. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen. 3, 3, 6, 7, 8, 9, 10, 11, 12 hydrogen. So molecular formula is perfect. But only difference what we have done is there with respect to their structure. But also in that structure also we are very much specific that whenever we are writing an iso structure, remember it is applicable to in all cases, the second carbon should contain the methyl group as a substituent. Okay, why I am saying this? Because in certain competitive exams they will not give you the IUPAC name. Of course the IUPAC name will be easy for you to write in both the cases. But in certain scenarios you have to remember the common names. So no need of by-hearting the common names. So this is the general way of remembering the N form and an iso form of any compound. So in an iso form, the second carbon atom should contain the methyl group as a substituent, and do remember it should have the same molecular formula of that of your N form, because it is an isomer of the N form. So why I have said this? Because if in case you have been given with an N-butanol and in the case of an isobutanol and you have been asked which among this one is having the higher boiling point? I repeat my question. You have been given with a question that you have been provided with an N-butanol and an isobutanol, and you have been asked that among these two structures, which is having the highest boiling point? What is your answer? I will give you the hint. It is similar to the hint of what we have observed in the chapter of your haloalkanes part, the physical properties. That is a straight chain and a branching. So what we have said earlier, as the branching increases, I repeat, as the branching increases, what happens? Yes, the boiling point decreases. So since in N-butanol there is no branching, of course N-butanol will be having the highest boiling point when compared to the isobutanol. Once again the question arises now, why is it so? Remember, as the branching increases, I repeat, as the branching increases, what happens? The surface area, you can only see, I am again repeating, as the branching increases, alva idu nodi ishtu dodda untu, iದೇ structure na branch ಮಾಡಿದಾಗ ಏನಾಯ್ತು, ಚಿಕ್ಕ ಆಯ್ತು. So what happens to the surface area? It decreases. As I have said earlier, what happens? As the surface area increases, van der Waals force was increasing. Now here what is happening? As the surface area decreases, van der Waals force also decreases, boiling point also decreases. So that is the case why your N-butanol is having the highest boiling point. Since it is lacking the branching, since there is no branching, of course the van der Waals force will be higher, boiling point will be higher. But in isobutanol we are watching that, or we are observing that there is a branching. So since due to the presence of the branching, what happens? Surface area decreases. Meanwhile, your van der Waals force increases, which will be resulting to the decrease in the boiling point. So what we can say? With increase in branching, what happens? With increase in the branching, boiling point decreases. Boiling point decreases. So we have come with respect to two important points with respect to the boiling point. What are those? First was, within a given compounds, that is, they are not the isomers, they are the totally different alcohols. There we have to see what? Their number of the carbon atoms. So with the increase in the number of the carbon atoms, the boiling point also increases because van der Waals force increases. But when you have been given with an isomer, that is, one is an N form and an iso form, so there we have to see that with the increase in the branching, what happens? Boiling point decreases. Is that clear? So this was we have to remember with respect to the boiling point, and in this case it is similar to what we have observed in the haloalkanes and haloarenes also. There also we have mentioned the same points. Is that clear? No doubt? Okay, let us now move to the next part within the boiling point itself. So now in case if you have been given with CH3, CH2OH, which is your ethanol, and you have been given with CH3, CH2 and CH3, that is your propane. So here now whatever the 2 points we were seeing, that was with respect to the alcohol itself. But now we are comparing it with some other organic compounds, that is alcohol with hydrocarbon. Here now the question arises that which one will be having the higher boiling point? Remember, it is a universal truth. Boiling point of alcohols, boiling point of the alcohol, and also your phenols, are always higher when compared to your ethers. It may be your hydrocarbons, or it may be your haloalkanes and haloarenes, of comparable molecular mass, So what does it mean? Let us understand. What is the meaning of this comparable molecular mass? You just find out the molecular mass of this compound. So we are having now 1, 2 carbons, so 24, 12 2s are 24. We are having 2 hydrogens, that is 3 plus 2, 5 hydrogens, so plus 5. Okay, 6 alwa. 3 plus 2 plus 1. So 6 hydrogens. And also we are having one oxygen. So what is its mass? 16. Alwa, 16. So what will be the overall? 6 plus 4, 10. Yes, 16. 2 plus 1, 3, 46. When I am coming with respect to the propane, you are having 3 carbons, 12 3s are 36. 3, 3, 6, 7, 8 hydrogens. Yes or no? So 36 plus 4, 40 plus 4, 44. So you can just see that it is 46, it is 44. Nearly comparable molecular mass. So whenever you have been given with such comparable molecular mass, do remember alcohols will be having the highest boiling point when compared to that of your, it may be your haloalkanes or it may be your haloarenes, even though it may be your ethers, even it may be your hydrocarbons. So when the question arises that now which of this will be having the higher boiling point, of course it will be our ethanol. Is that clear? Why is it so? Means many cases in your competitive exams they can give you ethanol, propanol and propane one ether form. One ether kottu kela chances irthe. Arrange it in the increasing order of their boiling point. Of course the alcohol will be having the highest part. So that will be at the last. Alva. So alcohol ige yavatte ನಾವು alcohol na haloalkanes ಜೊತೆ ನೀವು ಕಂಪೇರ್ ಮಾಡಿ ಅಥವಾ ethers ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ ಅಥವಾ hydrocarbons ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ, remember your alcohols will be having the highest boiling point. Now once again the question arises, why is it so? So let me now just compare my alcohols with ethers to answer this question. Alcohols with ethers. So in order to make sure that you can understand this, I had to come across with the two important concepts. What is that? One is called as an intermolecular hydrogen bonding. Intermolecular hydrogen bonding. And one more, intramolecular hydrogen bonding. Let me give you one common example. So if I talk about my nitrophenol, orthonitrophenol, okay, N double bond O and an O, and here you are having as an O and a H. So when I am observing this structure, I could see that here I am noticing my hydrogen bonding. Okay, this is not inter, it is intra. For the following example what I have given, intramolecular hydrogen bonding. Okay, but when I am considering for now intermolecular hydrogen bonding, intermolecular hydrogen bonding, let me write the structure for a paranitrophenol. Yes. So what are the two important things we could notify over here? See, when I'm talking about my intramolecular hydrogen bonding, I repeat, so when I'm considering my intramolecular hydrogen bonding, what we are observing, the hydrogen atom of a molecule has been bonded to an electronegative atom of an atom within the same molecule. Alva? So whatever the hydrogen bonding we are observing is it within the same molecule. That is called as what? Intramolecular hydrogen bonding. But when we talk about your intermolecular hydrogen bonding, what we are observing, the hydrogen atom of one molecule has been bonded to another atom, that is an electronegative atom of another molecule. So such a type of an hydrogen bonding is called as what? Intermolecular hydrogen bonding. Very much important concept. So whenever we are dealing with your boiling point concepts, ಏನ್ ಹೇಳುತ್ತೆ ಇಂಟ್ರಾ ಅಂದ್ರೆ ಏನು, hydrogen bonding is existing within a molecule, whereas an intermolecular ಅಂದ್ರೆ ಏನು, the hydrogen bonding is existing between two different molecules ಅಲ್ವಾ. ಮಾಲಿಕ್ಯೂಲ್ ಸೇಮ್ ಇರಬಹುದು, ಆದ್ರೆ ಏನಾಗ್ತಾ ಉಂಟು, ಇದು ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಆಗಿರುತ್ತೆ, ಇದು ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ಆತರ ಒಂದು ಎರಡು ಮಾಲಿಕ್ಯೂಲ್ ಜೊತೆ ಕಂಪೇರ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ನಾವು ಅದನ್ನ ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಅಂತೀವಿ. ಅದೇ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಇಂಟ್ರಾ, ಇಟ್ ಇಸ್ ವಿತ್ ಇನ್ ದಿ ಮಾಲಿಕ್ಯೂಲ್. Why I said this? So when I am observing the structure of my alcohols, there is in a common way if I write R O H, yes. So what I am observing is there we are seeing intermolecular hydrogen bonding. Intermolecular intermolecular hydrogen bonding. You can just see how they are bonding. R and an H. ಸೊ ಯಾವಾಗ ನಾನು ಒಂದು ಆಲ್ಕೋಹಾಲ್ ನ ಒಂದು ಬಾಟಲ್ ಅಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಆ ಬಾಟಲ್ ಇರೋ ಆಲ್ಕೋಹಾಲ್ಸ್ ದೇ ಹ್ಯಾವ್ ಬಿನ್ ಬಾಂಡೆಡ್ ಇನ್ ದಿಸ್ ವೇ. ಸೊ ದಿಸ್ ಟೈಪ್ ಆಫ್ ಎ ಬಾಂಡಿಂಗ್ ಇಸ್ ವಾಟ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಸೊ ಯಾವಾಗಲೂ ಈ ತರ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಬರ್ತಾ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಈ ಬಾಂಡ್ ನ ಬ್ರೇಕ್ ಮಾಡೋದು ಕಷ್ಟ. ಸೊ ನಾವು ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರೊವೈಡ್ ವಾಟ್ ಎಕ್ಸ್ಟ್ರಾ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ. ಸೊ ಆ ತರ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಕೊಡಬೇಕು ಒಂದು ಬ್ರೇಕ್ ಮಾಡಕ್ಕೆ ಅಂದಾಗ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ, ಅಫ್ ಕೋರ್ಸ್ ಇಟ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್. Why I have said this? So when I am comparing my alcohols with ethers, your ethers are lacking. What I am saying, your ethers are lacking this intermolecular hydrogen bonding. So therefore they can be easily broken off and they will be easily boiled off. ಆ ರೀಸನ್ ಇಂದ ನಾವೇನ್ ಹೇಳೋದು, your alcohols are having higher boiling point when compared to their isomeric ethers. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು ಸರ್? ಓಕೆ, ಲೆಟ್ ಮಿ ಗಿವ್ ಯು an example over here. CH3CH2OH ನ ಒಂದ್ ಕಡೆ ತಗೊಂಡಿದ್ದೀನಿ. ಸಿಮಿಲರ್ಲಿ CH3OCH3 ನ ಇನ್ನೊಂದ್ ಕಡೆ ತಗೊಂಡಿದ್ದೀನಿ. ಏನಿದು? ದೇ ಆರ್ ದಿ ಫಂಕ್ಷನಲ್ ಐಸೋಮರ್ಸ್ ಅಲ್ವಾ? ನೋಡಿ, ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಎರಡು ಕಡೆನೂ ಸೇಮ್. 2 ಕಾರ್ಬನ್ ಉಂಟು, ಇಲ್ಲೂ 2 ಕಾರ್ಬನ್ ಉಂಟು. ಹೈಡ್ರೋಜನ್ ಎಷ್ಟುಂಟು? 3, 4, 5, 6. ಹಿಯರ್ ಆಲ್ಸೋ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್ 3 + 3 6. 1 oxygen. So molecular formula should be same. But only difference is what? In the first case, it is an functional group is an alcohol. In the second case, the functional group is an ether. So when I am observing their boiling point, what I am observed is its boiling point is nearly 351 Kelvin. Whereas the boiling point of this ether, that is we call it as a methoxymethane. ಹಿಂಗೆ ನೇಮ್ ಮಾಡೋದಂತ ನಾನು ವಾಪಸ್ ನಾಮನ್ಕ್ಲೇಚರ್ ಆಫ್ ಈಥರ್ಸ್ ಅಲ್ಲಿ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಓಕೆ, ಬಟ್ ಯು ರಿಮೆಂಬರ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ as what? methoxymethane. So here boiling point what we are observing is nearly in the range of 248 Kelvin. So why, of course the question arises, why is it so? The answer is over here. Because in alcohols we can observe this intermolecular hydrogen bonding. So in alcohol such intermolecular hydrogen bonding is existing. Whereas in ethers, even though it is not having intermolecular, not even it is having an intramolecular. Since it is lacking this intermolecular hydrogen bonding, the ethers are having the lower boiling point when compared to that of your alcohols. Okay. One additional information let me give you over here. Remember, when compared to the inter and intra, when compared to now intermolecular hydrogen bonding and intramolecular hydrogen bonding, remember the boiling point of your intermolecular hydrogen bonding is very much higher. Boiling point of our intermolecular hydrogen bonding is very much higher when compared to that of your intramolecular. That is, in the given example now, if you have been asked with orthonitrophenol ಗೆ boiling point ಜಾಸ್ತಿನೋ ಅಥವಾ ಪ್ಯಾರಾನೈಟ್ರೋಫಿನಾಲ್ ಗೆ boiling point ಜಾಸ್ತಿನೋ, of course ಪ್ಯಾರಾನೈಟ್ರೋಫಿನಾಲ್ ಗೆ. ಯಾಕೆ? ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಅಂಡರ್ಗೋಯಿಂಗ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಯಾಕೆ ಸರ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಆದಾಗ ಯಾಕೆ ಅದ್ರ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ, ರಿಮೆಂಬರ್, ಬಿಕಾಸ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಆದಾಗ ದೇರ್ ಇಸ್ ಅನ್ ಅಸೋಸಿಯೇಷನ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್. ಏನಾಗ್ತಾ ಉಂಟು? ಅಸೋಸಿಯೇಷನ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು ನೋಡಿ, ಈ ಆಲ್ಕೋಹಾಲು ಒಟ್ಟಾಗ್ತಾ ಉಂಟು. ಈ ಆಲ್ಕೋಹಾಲ್, ಸೊ ದೇ ಆರ್ ಫಾರ್ಮಿಂಗ್ ಅ ಕ್ಲಸ್ಟರ್. ದೇ ಆರ್ ಕಮಿಂಗ್ ಅಂಡ್ ಫಾರ್ಮಿಂಗ್ ಅ ಕ್ಲಸ್ಟರ್ ಅಲ್ಲ. ಇಟ್ ಇಸ್ ಸಿಮಿಲರ್ ಟು ಅ ಸ್ಟೋರಿ which we were hearing in our childhoods. In order to break one stick, less energy is required. But in order to break a bundle of stick, more energy is required. The same scenario over here. Of course, you are knowing that story. One old man, in order to give his property for his sons, he gave them one task. That all of you bring one stick and break it. Then you bring a bundle of stick and then you break it. Of course, when they bought a single stick, it was easy to break. But when they applied the same energy to bake a bundle of stick, it was difficult. Why? Because cluster, whenever they form, they will be somewhat more stable. So in order to break that, we require enormous amount of energy. The same scenario is observed over here. So in intermolecular hydrogen bonding, what is happening? association of the molecule takes place. That is, all the molecules are coming together. So in order to break that, we require higher amount of energy. So therefore the boiling point also increases. But in the intra, what we have seen, whereas the molecule is within the, for whatever the bonding is there, it is within the molecule, so we can easily break it. So in intra, the boiling point is less when compared to the intermolecule. So therefore your para-nitrophenol will be having the highest boiling point when compared to that of your orthonitrophenol. Once again, note this point, very much important for your competitive exam. So what we came to know from this topic, when we are comparing with alcohols and ethers, of course your alcohols will be having the higher boiling point. Why is it so? Because in alcohols we are observing the intermolecular hydrogen bonding, which is lacking in your ethers. But an additional information I have also said, within an alcohols, if you are having an inter and an intra, of course our intermolecular hydrogen bonding will be having the higher boiling point, only because its association will be there and therefore resulting in the higher force to break the molecules, in turn resulting in the higher boiling point. Is that clear? Okay. Now coming to the next important part is our solubility. Solubility. Okay, before going to the solubility, of course, again and again you are giving the halo, means aliphatic alcohols ne ಹೇಳ್ತೀವಿ, ಅದರ ಒಂದು halo alcohols ne ಹೇಳಲ್ಲ ಅಂದ್ರೆ phenols ಬಗ್ಗೆ ತಗೊಳ್ಳೋಣ ಒಂದು example ನ. Let me take a phenol example in this way. OH, which is bonded with your CH3, 2-methyl phenol or your orthocresol. Orthocresol ನ ಒಂದು ಕಡೆ ತಗೊಳ್ತಿದ್ದೀನಿ. ಇನ್ನೊಂದು ನಾನು ether ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ, OCH3. Same as I have dealt with my aliphatic system, I have dealing with my aryl system. ಒಂದಲ್ಲಿ alcohol ತಗೊಂಡಿದ್ದೀನಿ, ಇನ್ನು ether. So this is your orthocresol. It is what? 2-methyl phenol. 2-methyl phenol. Basically it is called as an anisole, common name. Whereas this structure is called as what? Methoxybenzene. Methoxybenzene. ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು ಅಂತ ನಾವು nomenclature of ethers ಅಲ್ಲಿ ನೋಡ್ತೀವಿ. But just I will give you the hint. What is that? Remember, whenever a smaller group is present in your ethers, that will be said as an alkoxy group. What it will be called as an alkoxy group. The larger chain will be taken as your parent chain. ಆ ರೀಸನ್ ಇಂದ ಈಗ ಇಲ್ಲಿ ಬೆನ್ಝೀನ್ ಮತ್ತೆ ಮೀಥೇನ್ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಕನ್ಸಿಡರ್ ಯಾವ್ದು ಸ್ಮಾಲರ್ ಗ್ರೂಪ್, ಆಫ್ ಕೋರ್ಸ್ ಯುವರ್ ಮಿಥೈಲ್ ಗ್ರೂಪ್. ಸೊ ದಟ್ ಗ್ರೂಪ್ ವಿಲ್ ಬಿ ಸೆಡ್ ಆಸ್ ವಾಟ್? ಆಲ್ಕೋಆಕ್ಸಿ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಮೆಥಾಕ್ಸಿ ಬೆನ್ಝೀನ್. ಓಕೆ, ವೆನ್ ಬೋತ್ ವರ್ ಸೇಮ್ ನೋಮ್ ಪ್ಯಾಟರ್ನ್, ಮೆಥಾಕ್ಸಿ ಮೀಥೇನ್. ನಾವು ಇಲ್ಲಿ ನೋಡೋಲ್ಲ CH3 OCH3, both are same, so one will be alkoxy, another will be a parent chain. So methoxy methane. Don't worry, once again I will just recall this concept in our nomenclature. I just gave you a part. Again and again I am writing so that you should not get confused. ಹೆಂಗ್ ಬರಿತಿದ್ದೀನಿ ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಬೇಕಲ್ವಾ, ಆ ರೀಸನ್ ಇಂದ ಹೇಳಿದ್ದು. ಸೊ ಈಗ ನಂಗೆ ಕೊಟ್ಟಿರೋದು ಯಾವುದು? ಆರ್ಥೋಕ್ರೆಸಾಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅನಿಸೋಲ್ ನ ಕೊಟ್ಟಿದ್ದಾರೆ. Remember, now they have been asked which is having the higher boiling point. Of course, in this scenario also, orthocresol will be having the higher boiling point. So nearly it is having 464 Kelvin and it is having nearly 427 Kelvin. The reason is once again the same. So whenever we talk about your alcohols or phenols, they are having this intermolecular hydrogen bonding, which is not observed in your ethers. So due to the presence of this intermolecular hydrogen bonding, the boiling point also increases. Okay. Now coming to my next topic of physical property, which is called as what? Solubility. Of course, we can easily say whether alcohols are soluble in water or not. Boys, yes, you can easily say alcohols whether they are soluble in water or not. Yeah? Don't know. Recall, you are knowing it. In many of the films we have seen it. Whenever we are putting water to alcohol, can we see two layers? Of course, we are not able to see. Alva. So what does it says? Yes, alcohols are soluble in water. Alcohols are soluble in water. But here also you have to remember, what is that? Whenever organic compound is soluble in water means what? Yes, they are able to form hydrogen bonds with water. This is one of important thing. But most important thing I have to just once again deal with over here is, remember, lower membered alcohols are soluble in water. But the higher member alcohols are insoluble in water, or we can say they are partially soluble, or we can say what? Insoluble in water. What does it mean? Lower members means like your methanol, your ethanol, your propanol. So they are all lower membered alcohols. So they can easily get soluble in water because they can form hydrogen bonds with water. But when we come with respect to the higher membered alcohols like your hexanol, heptanol, sorbitol, so those are the alcohols in which we can see they are having the higher membered alcohols. They fall under the category of higher membered alcohols. And do remember, such higher membered alcohols are insoluble in water because they are not having such a capacity to form hydrogen bonds with water. So whenever an organic compound is not soluble in water means what? They are not having the capacity to form hydrogen bonding with water. This is the most important point you have to remember. Okay, lower membered alcohols are soluble in water, whereas your higher membered alcohols are insoluble in water. So in the physical properties we have seen with respect to the boiling point, and what are the things we have seen today's video? Yes, as the number of the carbon increases, the boiling point also increases due to increase in the van der Waals force. Then we came to know when you have been given with the two isomers, one is a straight chain and another a branch chain. Of course, our branch chain will be having the lower boiling point because there will be decrease in the surface area, and that will be resulting in the decrease in the magnitude of the van der Waals force. Since there is a decrease in the van der Waals force, what happens? Boiling point also decreases. Is that clear? So in simple words, what we can say, with the increase in the branching, boiling point decreases. Then we came with respect to the comparison of different functional groups of substituents. That is, when you compare to alcohols with your haloalkanes, haloarenes, ethers, or even it may be your hydrocarbons. Remember, alcohols are having the highest boiling point. Compared to alcohols and ethers, more specifically, alcohols are having the highest boiling point because due to the presence of your intermolecular hydrogen bonding. So there also we came to know with the two additional information. What is that? What do you mean by intramolecular hydrogen bonding, and what do you mean by intermolecular hydrogen bonding? What does it mean? Intra means the hydrogen bonding is existing within a molecule, whereas intra means the hydrogen bonding is present within the molecule, whereas an inter means the hydrogen bonding is existing between two molecules. ಆ ಪ್ಯಾರಾ ಪೊಸಿಷನ್ ಇದ್ದಾಗ ಅದು ಇಂಟರ್ ಮಾಡ್ಕೊಂಡಾಗ ಏನಾಗುತ್ತೆ? ಅಸೋಸಿಯೇಷನ್ ಆಫ್ ದಿ ಮಾಲಿಕ್ಯೂಲ್ ಆಗುತ್ತೆ. ಅಸೋಸಿಯೇಷನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ? ಮುರಿಯದ್ ಕಷ್ಟ, ಅವಾಗ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕೂಡ increase ಆಗುತ್ತೆ. Then we came across with respect to the solubility, and there we note that what? Low membered alcohols are soluble in water, whereas the high membered alcohols are insoluble in water. So next most important thing we are going to look in this video is with respect to the acidity of alcohols and phenols. I repeat, very much important topic. What is that? Acidity of your alcohols and phenols. So guys, now as I said, we are going to deal with the acidic nature of your alcohols and phenols. So we have to keep that one in mind. That's this topic we are going to study under chemical properties. So basically, when we are observing the chemical properties of this alcohols and phenols, they are mainly categorized into two major headings. One, in which we are going to see certain reactions which involves the cleavage. Cleavage means what? Breaking, which involves the breaking of OH bond. So when this OH bond breaks, what type of a reaction takes place? And also we are going to see the reaction which involves the breaking of C and an OH bond. Very much important. So in the first case, what happens when this bond breaks, your O will be having a negative sign. So there will be a nucleophilic attack of your alcoholic group. But in the second case, in this reaction, what we are observing, here the OH bond is going as it is, but it is breaking the bond between C and the OH. So in turn, it forms a carbocation. So both the reactions we are going to study in this chapter. But in today's video, we are mainly concentrating about the acidic nature, so which will be falling under the category of reactions which involve the breaking of your OH bond. So basically, when we talk about your acidic nature, or we can take, when we talk about alcohols and phenols, we say that they are acidic in nature. So of course, when we say that certain compounds are acidic in nature, we should have some justification for that. Alva. That is initially how we came to know that these alcohols and phenols are acidic in nature. So remember guys, one of the common and most important reaction, what we have observed, that whenever a substance is reacting with a metal, I repeat, whenever a substance is reacting with a metal, if that substance has the capacity to give hydrogen gas, so those substances are called as an acid. Yes. The same scenario was seen when the alcohols were treated with your alkali metals. That is, for example, I will be taking a general reaction, ROH, when it was treated with a sodium. So what did I got? Sodium alkoxide plus hydrogen gas liberation. So which was I can say a proof to say that my alcohols are acidic in nature. But one important point you should keep in your mind, of course they are acidic, but do remember they are weakly acidic. So therefore we require certain powerful reagents so that we can replace this hydrogen by our metal. So in that cases, certain cases we use our alkali metals and also we use our aluminium. So in case if you have been given with CH3CH2OH, in the presence of sodium, identify your A and B. You should make sure that your mind should switch in such a way that you should see, okay, here alcohol is being treated with a metal. So it is a reaction which involves to show that your alcohols are acidic in nature. So what is the product you are going to get? Yes, here whatever the hydrogen is there, it is going to get replaced by your sodium. So CH3CH2ONA plus H2. Since only one hydrogen is getting, but here we are getting a hydrogen molecule, so we have to balance the reaction. How is that? 2, 2 and here 2. Similarly in the general reaction also 2ROH given with respect to 2Na give rise to 2RONA plus H2. Yes. So this is an identification. But also we know one important thing. What is that? If a compound is acidic, generally we say that in a simplest way what we can say, yes, it has the capacity to donate a proton. Alva. Now hence we are saying that alcohols and phenols are acidic. What we are able to say, yes, they are having the capacity to donate a proton, that is H+. So first let us see the acidic nature of alcohols. Acidic nature of alcohols. How does this alcohols are able to give a proton? So basically whenever we talk an alcohol, remember whenever it is treated in a suitable solvent, it is in equilibrium to give an RO minus plus H plus. So this is a general reaction. How does your alcohol will be dissociating? Of course this is your alkoxide ion, alkoxide ion, and of course we know that it is a proton, which is showing that whatever the alcohol we have chosen is acidic in nature since it is giving a proton. But it doesn't stop over here. Why is it so? Major important thing lies over here is a comparison. Alva. Since we came to know that whenever an alcohol has to form an acid or to act as an acid, what it is giving is an alkoxide ion. So in our case, and arises that I will be giving you CH3 CH2OH as one alcohol, and if I give you CH3 twice CHOH, and one more I will be giving you as a CH3 thrice COH. Now my question is to you that among three alcohols, which is highly acidic? Which is highly acidic? What will be your answer? Recall. Concept is easy. It mainly depends upon this alkoxide ion, or in simple words I can say the stability of this alkoxide ion. Let me write it one by one. So when I take this alcohol according to this reaction, what I am going to get? Yes, CH3, CH2, O minus. Yes? Okay. In the second case, what happens? CH, CH3, CH3. In the third case, C, O minus, CH3, CH3 and a CH3. So what we are observing over here is very much important. Of course we know what alkyl groups are electron donating groups. I repeat, alkyl groups are electron donating groups. Yes. How did I write this one is very much important because we know that whenever we are choosing an alcohol, of course in a suitable solvent is going to give an alkoxide ion. I have written their respective alkoxide ion. Now what I am saying is a number of the alkyl groups present. So in the first case, you could just see that only one alkyl group is present. Alva. And we know what? Alkyl groups are electron donating groups. Electron donating groups. This is one important thing. Whereas in the second case, what I can say, you are having only one alkoxy group. In the second case, you are having two alkyl groups. Alva, two alkyl groups. Whereas in the third case, you are having three alkyl groups. This is first hint. You are act now like a detective. Okay, you have been given with a case over here. Who is the culprit we have to see. So in this culprit, we have to choose that which is having the highest or which is highly acidic. To say which is highly acidic, we should come to a point. What is that? Which compound can give H plus at a faster rate? Alva? ಯಾವುದು ಕಂಪೌಂಡ್ ತುಂಬಾ ಬೇಗನೆ H plus ಕೊಡುತ್ತೋ ಅದು highly acidic. Alva? What we know, the compound which gives H plus is acidic, we were knowing. But when all the compounds are alcohols, now we have to see that among these three alcohols, which has the capacity to give H plus at a faster rate. ಯಾವ alcohol ಈ ಮೂರರಲ್ಲಿ ತುಂಬಾ ಬೇಗನೆ H plus ಕೊಡಕ್ಕೆ ಸಾಧ್ಯ ಅನ್ನೋದನ್ನ ನಾವು ನೋಡಬೇಕು ಅಲ್ವಾ. So now let us check out which is that possible. So of course here when we are saying this part, what we can see, here also there is a negative sign, here also there is a electron donating group. Yes, here also there is a negative sign, here also there are two such donating groups, here also there is a negative sign, here there are three electron donating groups. So here we have to study the stability of your alkoxide ion. I repeat, the stability of your alkoxide ion. I repeat once again, whenever a reaction has to proceed, what I have said, it has to lead a stablest condition. ಯಾವುದು ತುಂಬಾ ಸ್ಟೇಬಲ್ ಕಂಡೀಷನ್ ಇರುತ್ತೋ ಆ ರೂಟ್ ನ ಅದು ಫಾಲೋ ಮಾಡುತ್ತೆ. ಈಗ ನಾನು ಫಸ್ಟ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಏನಾಗಿದೆ, ಇಲ್ಲೂ ಎಲೆಕ್ಟ್ರಾನ್ ಉಂಟು, ಇದು ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡುತ್ತೆ. ಅಫ್ಕೋರ್ಸ್ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ. ಇಲ್ಲೂ ಉಂಟು, ಇಲ್ಲಿ ಅಂದ್ರೆ ಎರಡು ಸಚ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಷನ್, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲೂ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ, ಇಲ್ಲೂ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ. ಆದ್ರೆ ರಿಪಲ್ಷನ್ ಜಾಸ್ತಿ ಆಗ್ತಿರೋದು ಯಾವ್ದ್ರಲ್ಲಿ? ಹಿಯರ್. ಯಾಕೆ? ಬಿಕಾಸ್ here three such electron donating groups are there. So such electron donating group, what happens? There will be maximum repulsion. Maximum repulsion. And here there will be minimum repulsion. So what I am observing over here is this stability of alkoxide ion. So ಈ ಒಂದು ಕಂಪೌಂಡು H plus ನ ಕೊಟ್ಟರೂ ಕೂಡ ಏನಾಗಿರುತ್ತೆ, ರಿಪಲ್ಷನ್ ಕಮ್ಮಿ ಇರುತ್ತೆ, ಸೊ ಸ್ವಲ್ಪ ಸ್ಟೇಬಲ್ ಇರುತ್ತೆ. ಆದ್ರೆ ವೆನ್ ಐ ಆಮ್ ಕನ್ಸಿಡರಿಂಗ್ ಫಾರ್ ಮೈ ಟರ್ಷರಿ ಪಾರ್ಟ್, ತ್ರೀ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ಸ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಅದೆಲ್ಲಾದ್ರೂ H plus ಕೊಡ್ತು ಅಂದ್ರೆ ಏನಾಯ್ತು, ತ್ರೀ ಗ್ರೂಪ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ವಿಚ್ ಇಸ್ ಆಲ್ಸೋ ಎಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಟಿಂಗ್ ಗ್ರೂಪ್ಸ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ, ಲೆಸ್ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ಆ ಒಂದು ಕಾರಣದಿಂದ ಏನಾಗುತ್ತೆ, ಎಸ್ my primary alcohols will be more acidic when compared to my secondary alcohol. Yes, and the least acidic will be my tertiary alcohol. Are you able to understand what I am saying? Yes. So our acidic strength depends upon this order. Very much important. So primary alcohols are more stable because due to the stability of their alcohol oxide ion, only one electron donating group is present. In secondary alcohol, only two are present. But in tertiary alcohol, why it is least? Because there are three such electron donating groups, which in turn leads to the instability or less stability of your alcohol oxide ion. ಅಲ್ವಾ? ಸೊ ಇದನ್ನ ಕೊಟ್ಟಾಗ H+ ಬೇಗನೆ ಕೊಟ್ಬಿಡುತ್ತೆ. H+ ಯಾಕೆ ಬೇಗ ಕೊಡುತ್ತೆ ಅಂದ್ರೆ ಫಾರ್ಮ್ ಆಗ್ತಾನೆ ಆಲ್ಕೋ ಆಕ್ಸೈಡ್ ಅಯಾನ್ ಕೂಡ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ದಟ್ ಇಸ್ ದ ರೀಸನ್. ಸೊ ವೆನೆವರ್ ಯು ಹ್ಯಾವ್ ಬಿನ್ ಗಿವನ್ ವಿತ್ ನೌ ದೀಸ್ ತ್ರೀ ಟೈಪ್ಸ್ ಆಫ್ ಆಲ್ಕೋಹಾಲ್ಸ್, ದಟ್ ಇಸ್ your primary alcohol, secondary alcohol and tertiary alcohol, and you have been given with a question. Arrange them in the decreasing order. I repeat, arrange them in the decreasing order of your acidic strength. Remember, your primary alcohols will be highly acidic, secondary alcohol somewhat acidic, tertiary alcohol will be the least acidic. Are you able to getting my point? Why it is so? It is mainly because of the stability of alcohol oxide ion. Is that clear? Okay. Now let me come with the acidic nature of phenols. Acidic nature of phenol. Do remember, whenever we talk about your phenol, when it is treated with the water, it is giving you this reaction. That is our phenoxide ion. Yes. Plus H+. Of course, by the reaction we have come to know that yes, phenol is acidic in nature. But here we have to understand one important thing, that how does it is giving this product. Alva. So in order to understand this, we have to understand the resonance structure of phenol. Resonance structure of phenol. What is that resonance structure speaks? Let us see. Very much important because 100% this question can arise. Explain the acidic nature of the phenol by taking the resonance structure of the phenol anta kela chances untu. There is a one more explanation which I will be giving in this video itself. That is by taking the resonance structure of phenoxide ion. First let us see about phenol. Why it is giving this H+. So basically when I am talking about my phenol, of course we know what your oxygen is having a lone pair of electrons. So this lone pair of electrons will be given to the benzene ring. So ಏನಾಗುತ್ತೆ, electron density ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಈ electron ಏನಾಗುತ್ತೆ, ಈ carbon ಎಳ್ಕೊಳ್ಳುತ್ತೆ. So ಅವಾಗ ಏನಾಯ್ತು, very much important, whenever you're writing the resonance structures, the plus and the negative signs are very much. ಇಲ್ಲಿ ಏನಾಯ್ತು, double bond character ಆಯ್ತು. ಆಕ್ಸಿಜನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಟ್ಟಿದೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಕಾರ್ಬನ್ ಈ ಹತ್ರ ಬಂತು, ಇಲ್ಲಿಗ ನೆಗೆಟಿವ್, here and here. It doesn't stop. So now once again, now it will form a pi bond. Now this electrons will move to this carbon. So now you will be getting, yes, double bond O and a H. Here you will be having a plus. Here one, and here negative sign. Now this would be given. Here they will be taken. So again, yeah. So here negative. Here one, here double bond O plus and a H. Let me continue. So here, so now this would be given, this would be taken. So what happens? Yes, like this, single bond OH. But what we can observe, if I give the numbers to the structure, first, second, third, fourth and fifth, what I am observing in this structure is, in the structure of second, third and fourth, we are observing that oxygen is having a positive charge. Yes. So what it will happen means, among this resonance structure, your second, third and fourth are highly unstable. They are what? Highly unstable. So what they try to do is, they will try to take the shared pair of electrons. I repeat, the oxygen will try to take the shared pair of electrons which has been shared between oxygen and hydrogen towards itself. So when it is happening, so what happens? This OH ka bond, what is there? It will try to take towards itself. So what happens? Your H+ gets released. So that is the reason why we are saying that your phenols are acidic in nature. So this was the explanation which was given by our resonance structure of phenol. But of course, one important thing we have to note over here. What is that? So when our phenol is treated with water, it is giving a phenoxide ion. What is the stability of this structure? Why it is forming? So that one also seen under the concept, the resonance structure of phenoxide ion. Phenoxide ion. So basically, when it is giving that H plus, of course we have seen that it is forming an O minus. Yes. But do remember, whatever the negative charge over oxygen is there, they are involved in delocalization. That is, once again, give the same thing. Yes. So here now we will be having double bond O plus. No, not a plus. Double bond. So here you will be having a negative. Yes, here one bond, here one bond. Here it would be taken. Are you able to see? So this would be given. So you could just see that double bond O, here one structure, here minus. See how I'm writing? Like this itself you have to write. Arrow mark notations are very much important. Double bond O. Once again it gives, it takes, and you will be having, So here O minus. So what we are observing over here is, in the resonance structures, we are mainly seeing that whatever the negative charge was there present on the oxygen, they are not remained as such, whereas they have been delocalized. So whenever there is such a delocalization, what happens? Stability increases. Alva? Yake benzene is stable anta heltevi? Because only due to the delocalization of the pi electrons. Illu kuda enagta untu, whatever the negative charge was present on the oxygen, they are involved in the delocalization. You can just see how they are rotating. So which in turn what happens? The stability of that phenoxide ion increases. So what is the important point we are coming to know from this structure is, when we compare the phenol to that of your phenoxide ion, we are observing that your phenoxide ion is more stable. Phenoxide ion is more stable. So of course we know always a structure or a compound try to be in its most stable state. So whenever we take a phenol in a system, it will always try to give the H plus and go to the more stable state. So that is the reason. So ಇದು ಫಾರ್ಮ್ ಆಗಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕದು? H plus ನ ಕೊಡ್ಲೇಬೇಕು. H plus ನ ಕೊಡ್ತಾ ಉಂಟಾಗ ಏನ್ ಆಕ್ಟ್ ಆಗುತ್ತೆ? ಆಸಿಡ್ ಹಂಗೆ ಆಕ್ಟ್ ಆಗ್ಲೇಬೇಕು. ಆ ರೀಸನ್ ಇಂದನೇ phenols are acidic in nature. So we have seen why phenols are acidic in nature in the two important conditions. One, we have studied the resonance structure of the phenol. Since in the resonance structure of the phenol, what did we observe? The second, third and the fourth structures are unstable. Because oxygen being having a positive charge, it will try to break the bond between O and H, and it will try to take that shared pair of electrons towards itself. So when it takes, what happens? Easily H plus gets released. But once it gets released, what happens? It will be forming a phenoxide ion. Of course it is forming a phenoxide ion. Why? Because whatever the negative charge is present on the oxygen, it is once again involved in the resonance. Once it is resonance involved agide andre artha eno, it has been delocalized. So in turn enagutte, phenoxide structure will be more stable. So phenol ಮತ್ತೆ phenoxide ion ನಾವು ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಯಾವುದು ತುಂಬಾನೇ ಸ್ಟೇಬಲ್ ಅಂದ್ರೆ phenoxide is more stable. ಸೊ ಆ ರೀಸನ್ ಇಂದಾನೆ ಯಾವತ್ತೇ ನಾವು ಫಿನಾಲ್ ನ ಒಂದು ಬಾಟಲ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡಿದೀವಿ ಅಂದಾಗ ಅದೇನಾಗಿರುತ್ತೆ, ಅದು ಈ ಸ್ಟ್ರಕ್ಚರ್ ಇರೋದು ಕಡಿಮೆ, ಏನಾಗಿರುತ್ತೆ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಈ ಸ್ಟ್ರಕ್ಚರ್ ಇರ್ಬೇಕಂದ್ರೆ ಅರ್ಥ ಏನು? H ಪ್ಲಸ್ ನ ಕೊಡ್ಲೇಬೇಕು. ಆ ರೀಸನ್ ಇಂದಾನೆ ಯಾವತ್ತೇ ನಾವು ಫೆನಾಲ್ ನ ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ವಿ ಶುಡ್ ಬಿ ಅಟಮೋಸ್ಟ್ ಕೇರ್ ಶುಡ್ ಬಿ ಟೇಕನ್. ವೈ? ಬಿಕಾಸ್ since it has been released at H plus, it will be in the acidic state. So whenever it falls on our body, it is highly corrosive. Able to understand? So that is the reason your phenols are acidic in nature. But one important thing what we have to note over here is what? ಎಷ್ಟು ಬೇಗ ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬೆನ್ಸಿನ್ ಎಲ್ಕೊಳುತ್ತೋ ಅಷ್ಟು ಬೇಗ ಅದು ಅಸಿಡಿಕ್ ಅಲ್ವಾ? ಯಾಕೆ ಇದನ್ನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ, now the question arises, what happens if an electron withdrawing group is present electron withdrawing group is present and an electron donating group is present. Both is important. ಸೊ ಆ ರೀಸನ್ ಇಂದನೇ ಈ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್. ಏನಂತ ನೋಡಿದ್ವಿ ನಾವು, ಯಾಕೆ ನಮ್ಮ ಫಿನಾಕ್ಸೈಡ್ ಅಯಾನ್ ಸ್ಟೇಬಲ್ ಅಂದ್ರೆ ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಏನಾಗಿದೆ ಒಳಗೆ ಎಳ್ಕೊಂಡಿದೆ, ಡಿಲೋಕಲೈಸೇಷನ್ ಆಗ್ತಾ ಉಂಟು. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನ್ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ, ಎಲೆಕ್ಟ್ರಾನ್ ವಿಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ ಇದ್ರೆ ಫಿನಾಕ್ಸೈಡ್ ಅಯಾನ್ ಅಸಿಡಿಕ್ ನೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೋ, ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಟಿಂಗ್ ಗ್ರೂಪ್ ಇದ್ರೆ ನಿಮ್ಮ ಫಿನಾಲ್ ಅಸಿಡಿಕ್ ಆಗಿರುತ್ತೋ ಅನ್ನೋ ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಆ ರೀಸನಿಗೆ ನೀವು ಆನ್ಸರ್ ಮಾಡ್ಬೋದಾ? ಏನ್ ಹೇಳ್ಬೋದು ನಾವು, ಎಲೆಕ್ಟ್ರಾನ್ ವಿಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಟೇಕ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಟ್ ಅ ಫಾಸ್ಟರ್ ರೇಟ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅತಿ ಬೇಗ ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ತನ್ನ ಕಡೆ ಗೆಲ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ವೆನ್ ಇಟ್ ಇಸ್ ಟ್ರೈಂಗ್ ಟು ಡೂ ಸೊ, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಅಟ್ ಅ ಫಾಸ್ಟರ್ ರೇಟ್ H plus will be released ಅಲ್ವಾ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಏನ್ ಹೇಳ್ತೀವಿ, ವೆನೆವರ್ an electron withdrawing group is present in a phenol, the acidic strength increases. Are you able to understand? ಬರೀ ಫಿನಾಲ್ ಇದ್ದಾಗ ಏನ್ ಮಾಡ್ತು, ಅಫ್ಕೋರ್ಸ್ ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ O ಮೈನಸ್, ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೊಂಡುತ್ತೆ. ಯಾಕೆ, ಇಲ್ಲೂ ಎಲೆಕ್ಟ್ರಾನ್ ಉಂಟು, ಆಕ್ಸಿಜನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಷ್ಟೇನು ಬೇಡದಿತ್ತು, ಆದ್ರೂ ಕೂಡ ಅದೇನ್ ಮಾಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಜಾಸ್ತಿ ಇರೋ ಕಾರಣ ತಗೋಬಿಡುತ್ತೆ, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಸ್ಟೇಬಲ್. ಅದೇ ಇದೇ ಫಿನಾಲಿಗೆ ಒಂದು NO2 ಗ್ರೂಪ್ ಅಟ್ಯಾಚ್ ಆಗಿದೆ ಅಂದಾಗ ಏನಾಗುತ್ತೆ, ಈ NO2 ಗ್ರೂಪ್ ಏನ್ ಮಾಡುತ್ತೆ, ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತಗೋಬಿಡ್ತು, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಕಮ್ಮಿ ಆಯ್ತು, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲಿಗೆ ಬರಕ್ ಚಾಲು, ಅವಾಗ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ, ಬೇಗನೆ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ನಾವೇನ್ ಹೇಳ್ತೀವಿ, ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಅಸಿಡಿಕ್ ಸ್ಟ್ರೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಟಿಂಗ್ ಗ್ರೂಪ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಅಫ್ಕೋರ್ಸ್ ಅದ ಹತ್ರ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಉಂಟು, ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತಾ ಉಂಟು, ನಾನು ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಡೊನೇಟ್ ಮಾಡ್ತೀನಿ ಅಂದಾಗ ಏನಾಗುತ್ತೆ, ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ, ಅವಾಗ H+ ಬೇಗನೆ ಬಿಟ್ಕೊಡಲ್ವಾ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅಸಿಡಿಕ್ ಸ್ಟ್ರೆಂತ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್, ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು, what will be the acidic strength of the phenols in the case if you are having an electron withdrawing group? So you should say, in case a phenol is having an electron withdrawing group, the acidic strength increases. Whereas if it is having an electron donating group, the acidic strength decreases. Is that clear? And moreover, an important note you have to remember, whenever your electron withdrawing group is present in the ortho and the para position, the acidic strength increases, but not in the case in your meta position. Why is it so? You only write the resonance structures, you will come to know why I am saying so. So what we came to know, of course, by the presence of an electron withdrawing groups, what happens, acidic strength increases, whereas an electron donating group idaga enagutte, acidic strength decreases. Moreover, if the electron withdrawing groups are present in the ortho and the para position, yes, ortho and the para position iddaga enagutte, acidic strength increase agutte. Ade meta position ittu andre acidic strength decrease agutte. Okay, now let me ask you a question. Whether water is acidic or alcohol is acidic, which is more acidic? I repeat, whether water is acidic or your alcohol is acidic, which is more acidic? Recall, of course, water acidic anta keltidine artha enu, H+ na kodbeku. H+ na kodbeku andre artha enu, OH- na form ಮಾಡ್ಕೊಳುತ್ತೆ. ಅದೇ ಇಲ್ಲಿ ROH ಏನ್ ಮಾಡ್ಕೊಳುತ್ತೆ, RO- na form ಮಾಡ್ಕೊಳುತ್ತೆ. ನಾ ಏನ್ ಹೇಳಿದ್ದೆ, ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ ಆಲ್ಕೋಕ್ಸೈಡ್ ಅಯಾನ್ ಇಸ್ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಇಲ್ಲಿ ಯಾವ ತರದ್ದು ಎಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಟಿಂಗ್ ಗ್ರೂಪ್ ಇಲ್ವೇ ಇಲ್ಲ ಅಲ್ಲ ವಾಟರ್ ಅಲ್ಲಿ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ರಿಪಲ್ಷನ್ ಯಾವ ತರದ್ದು ಮೀನ್ಸೇ ಅಲ್ಲಿ ಅರೈಸ್ ಆಗಲ್ಲ. ಆದ್ರೆ ಇಲ್ಲೇನಾಗ್ತಾ ಉಂಟು, ದೋ ಸೆಕೆಂಡರಿ ಟರ್ಸರಿ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಒಂದೇ ಇತ್ತು, ಅದಕ್ಕೆ ನಾ ಏನ್ ಹೇಳ್ತೆ, ಆಲ್ಕೋಹಾಲ್ ಇಸ್ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಇಸ್ ಅಸಿಡಿಕ್. ಬಟ್ ಆಲ್ಸೋ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ವೆನ್ ವಿ ಆರ್ ಕಂಪೇರಿಂಗ್, there is no alkyl group and there is an alkyl group, what happens here, mutual repulsion takes place. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇದ್ರದ್ದು ಸ್ಟೆಬಿಲಿಟಿ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, water can easily act as an acid when compared to that of your alcohol. So therefore we say that water is stronger acid. Water is stronger acid when compared to alcohol. Very much important. And the same thing if I ask you whether your aliphatic alcohols are more stable or your phenol is more stable. That is, for example, if I give you as a methanol and a phenol, which is more acidic? Which is more acidic? Remember, your phenols will be more acidic. Why is it so? Because whatever the phenoxide ion it has been formed, it is stable. Alva, it is stable. That is by its resonance structures we have seen. Adhe riti, whatever the alkoxide ion which will be formed in your aliphatic alcohols, they are unstable. So our reason indane, our phenols are more acidic. Phenols are more acidic compared to our normal alcohols. That is, compared to our aliphatic alcohols. One more important note you have to remember. ಯಾಕೆಂತ ಅರ್ಥ ಆಯ್ತಾ? ಬಿಕಾಸ್ ಫಿನಾಲ್ ಫಿನಾಕ್ಸೈಡ್ ಅಯಾನ್ ಕೊಡುತ್ತೆ, ಅದು ಸ್ಟೇಬಲ್. ಅದೇ ರೀತಿ ನಾರ್ಮಲ್ ಆಲ್ಕೋಹಾಲ್ ಆಲ್ಕೋಆಕ್ಸೈಡ್ ಕೊಡುತ್ತೆ, ಬಟ್ ವಾಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್? ಇಟ್ ಇಸ್ unstable. But what is the important point we have to keep in our mind in the overall thing is, remember, so whenever an electron withdrawing group is present in an ortho and the para position, of course the acidic strength increases. If an electron donating group is present, the acidic strength decreases. One important point. And the most important point, in case if you have been given H2O, CH3OH, and you have been given with OH, and you have been given with OH, NO2, and you have been asked a question, arrange the following or arrange the above case in the increasing order of their acidic strength. Increasing order of acidic strength. So ಏನು ಮಾಡ್ತೀರಾ, ಹೇಗೆ ಮಾಡ್ತೀರಾ? Recall fast. Of course we know what, compared to H2O. H2O is what? Highly acidic. Okay, ಈ ಕನ್ಫ್ಯೂಷನ್ ಬೇಡ. ಫಸ್ಟ್ ಇದು ನಾವು ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ. ಇದನ್ನೇ 3 ಕೊಟ್ಟಿದ್ದೀನಪ್ಪ, ಇದನ್ನ ಈಗ ನಾವು ಲೆಕ್ಕ ಹಾಕಬೇಕು. So you have been given with methanol, you have been given with a phenol, and you have been given with an electron withdrawing group, that is nitro group attached to phenol, which is highly acidic. Arranged in increasing order. First what we have to think, okay, first is our aliphatic alcohol, and then we have to check aromatic alcohol. And what we know, of course, aromatic alcohols are more stable. So this will be what? The least one. Okay, CH3OH. Yes, this will be what? Least. Next, within the aromatic alcohols, what we know, if an electron withdrawing group is present, I repeat, if an electron withdrawing group is present, of course it increases the acidic strength. Alva? So ಅವಾಗ ಏನಾಗುತ್ತೆ, ಬರೀ ಫಿನೋ ಆಲ್ಕೋಹಾಲಿಕ್ ಗ್ರೂಪ್ ಮಾತ್ರ ಉಂಟು, ಯಾವ ತರದ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ ಇಲ್ಲ. ಸೊ somewhat it is stable. ಅಲ್ವಾ? But the highest acidic strength ಇರೋದು ಯಾವುದು? Yes, the nitro substituted alcohol. Able to see? Why is it so? Here itself the overall concept lies. Compared to normal alcohols and your aromatic alcohols, our aromatic alcohols are stable. Within an aromatic alcohol, the electron withdrawing group present, they will be having the higher acidic strength. Is that clear? So now if we take H2O, CH3OH and your phenol, which is more acidic? Do remember guys, when we compare water with an aliphatic alcohol, as I have seen, remember, your water is highly acidic. I repeat, your water is highly acidic. But when we compare your water with a phenol, your phenol is highly acidic. Why is it so? Of course, in this reaction we have seen. So when phenol is treated with a water, it is giving a phenoxide ion. Alva? So this phenoxide ion, what is there? It is resonance stabilized. Athwa in major ಆಗಿ ಹೇಳಬೇಕು ಅಂದ್ರೆ, ಯಾವಾಗ ನಿಮ್ಮ ಫಿನಾಲ್ H+ ನ ಕೊಡುತ್ತೆ, ಅದೇನಾಗುತ್ತೆ? ಫಿನಾಕ್ಸೈಡ್ ಅಯಾನ್ ನ ಕೊಡುತ್ತೆ. This phenoxide ion, it is highly stable. So ಅದೇನ್ ಮಾಡುತ್ತೆ? Phenol will try to give H+, so that it can go to the stable state. But when water should give an acid, of course what it will do? OH minus. Of course this hydroxide ion has been formed, but it is not resonance stabilized. It is not stabilized part. So ಆ reason ಇಂದ ಏನಾಗುತ್ತೆ, water will not try to give H plus. So ಆ reason ಇಂದ ನಾವೇನ್ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ, of course remember, compared to, I will just make a note, compared to aliphatic alcohols and water, aliphatic alcohol and water, remember, water is highly acidic. Water is highly acidic. But when I'm comparing my water and my phenol, remember, phenol is highly acidic. Phenol is highly acidic. Why is it so? Because by the stabilization of phenoxide ion. Stabilization of phenoxide ion. That means what? If I take water, if it has to act as an acid, what it has to do? It has to form OH minus plus H plus. Whereas phenol, if it has to act as an acid, what it should do? Yes, it has to form a phenoxide ion. It has to form a phenoxide ion plus H plus. ಯಾವತ್ತೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಪ್ರೊಸೀಡ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಏನಂತ ಹೇಳಿದ್ದೆ, ಅದು ಸ್ಟೇಬಲ್ ಸ್ಟೇಟ್ ಗೆ ಹೋಗುತ್ತಾ ಅನ್ನೋದನ್ನ ಅದು ಕಾಯುತ್ತೆ. ಫಿನಾಲ್ ಫಿನಾಕ್ಸೈಡ್ ಹೋಗಿ ಏನಾಗುತ್ತೆ, ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲೈಸ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಏನ್ ಮಾಡುತ್ತಿದ್ದು, ಓಕೆ H ಪ್ಲಸ್ ನ ಕೊಟ್ಟಿ ನಾನು ಸ್ಟೇಬಲ್ ಗೆ ಹೋಗ್ಬಿಡೋಣ, ಸೇಫ್ ಝೋನಿಗೆ ಹೋಗೋಣ ಅಂತ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ ಅದು ಮಾಡುತ್ತೆ, ಯಾಕಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ದಿ ಸ್ಟೇಬಲೆಸ್ಟ್ ಸ್ಟೇಟ್. ಅದೇ ವಾಟರ್ ಏನ್ ಮಾಡುತ್ತೆ, H plus na kotti OH minus adaga, it is not stable. So what it will try to do, it will be try to remain as water itself. But do remember, when this water reacts with that of your normal alcohols, that is aliphatic alcohols, what happens, your RO minus enuntalva, that will try to react with water. ROH I convert agi, once again it forms OH minus. Ilenagta untu andre, we could just see that whatever the alkoxide ion of your aliphatic system was there, okay, that is once again reacting with water and accepting a proton. So this part, that is your alcohol, acts as a Bronsted base. ಆ ರೀಸನ್ ಇಂದ ನಾವೇನು ಹೇಳೋದು, your water is highly acidic when compared to the aliphatic alcohol. But when we are comparing your phenol, remember, water and phenol, your phenol will be highly acidic. So how can you now rearrange this part? Yes. So compared to water and methanol, yes, your methanol is what? Least acidic. So first yaad barbeku, CH3OH. But when compared to water and the phenol, which is the highest, phenol is the highest, so the last should be our phenol, which is highly acidic. So important points you have to remember. So when compared to water and alcohol, your water is highly acidic. But when compared to water and the phenol, your phenol is highly acidic. Why is it so? It is because due to the stabilization of phenoxide ion. In this case, why water is highly acidic? Because your aliphatic system, aliphatic alcohol, acts as a Bronsted base. Instead of giving a proton, it tries to take a proton. So that is the reason it is somewhat weak acidic when compared to that of your water. Are you able to understand? So in this concept, we have come to know the major important things. What is that? Of course, alcohols and phenols are acidic in nature. But when we are saying the alcohols only, we came to know that your primary alcohols are highly acidic compared to secondary alcohol, and your tertiary alcohols are least acidic. And the main reason for that was due to the stability of your alkoxide ions. Okay. Coming with respect to the phenols, we came to know, of course, phenols are also acidic in nature, and we also explain it with respect to the two important concepts. Remember, both the concepts are important. They can ask any of one in your exam. So in phenols, we see that there is in the structure second, third, and fourth, there is existing a positive charge. So therefore, the OH bond cleavage takes place. So O negative happens, and it will be giving you as a proton. So it acts as an acid. So once it has been formed as a phenoxide ion, it is also resonance stabilized. So always the phenol will try to enter to the most stable state, that is your phenoxide ion, and therefore it is only possible when it gives as a H plus. So therefore we say that your phenols are acidic in nature. And moreover, we also came to know that whenever an electron withdrawing group is present to the phenol in the ortho and the para position, the acidic strength increases. But when an electron donating group is present to the phenol system, the acidic strength decreases. Okay. Then we also came to know when we are comparing your alcohols with your water, we know that your water is highly acidic. Yes. But when the same water is compared with your phenol, we came to know that your phenol is more acidic. These two important examples we have given, which is very much important in your competitive exams also. Okay. So in our next video, we are going to see certain important chemical reactions of our phenols and alcohols. Okay.